There are two types of contact prevention. First is preventing contact between one group of surfaces. This F for preventing contact between one group of surfaces. One group contact prevention surface makes sure that all surfaces within the group do not touch. To activate this option, right-click the operations, then Surface Wrapper, then Contact Prevention node and select One Group Contact Prevention Set. The next type is preventing contact between two groups of surfaces. This is for preventing contact between two groups of surfaces. Two-group contact prevention makes sure that the surfaces between the two groups do not touch, but surfaces within groups can touch. To activate this option, right-click the operations, then Surface Wrapper, then Contact Prevention node and select Two-Group Contact Prevention Set. After a detailed study of Surface Wrapper, we will now turn our attention to another type of surface mesh operation which is called a surface remeshing. The surface remesher is used to retriangulate an existing surface in order to improve the overall quality of the surface and optimize it for the volume mesh models. What are the features of surface remeshing? It can be used for localized refinement based on surfaces, or boundaries can also be included. The surface remesher is used for remeshing surfaces produced either by the surface wrapper or directly from CAD import. The surface remesher should always be used before volume meshing takes place. We will review the user inputs for surface remeshing. The input values used for the surface remesher can be adjusted on different levels. We can provide the user inputs as parts-based meshing. In this case, we go to Mesh Operation and give default controls, which will set default controls for all parts. We can also use Mesh Operation and provide custom controls. In this case, we can customize the setting on individual part basis for parts, surfaces, and curves. If we are using region-based meshing approach, we have to give the user inputs for remeshing at mesh continuum as reference values. Reference values are given at region, boundary, feature curve, and interfaces. There is also the surface remesher volumetric controls user input. These can be included to further optimize the resulting surface triangulation. After surface mesh operation, we will now study volume mesh generation. Before we start studying the process of volume mesh generation, some quick prerequisites for volume mesh. The cause for a bad volume mesh very often is a bad surface mesh, as it has a direct influence on the quality of the resulting volume mesh. The generation of the surface mesh should be considered carefully. The more care you take during the preparation of your surface mesh, the better quality has the resulting volume mesh. The surface repair tool can be used to check the quality of the remeshed surface before volume meshing. One by one, we will see what different types of volume mesh are available in Star CCM Plus. First is the Delaunay-based method. Delaunay-based method is used to construct the mesh which iteratively inserts points into the domain. The starting quality of the surface mesh must be good in order to ensure a good quality volume mesh. Next, we have the dualization scheme. Dualization scheme is used based on an underlying tetrahedral mesh which is automatically created as parts of the process. The polyhedral cells created typically have an average of 14 cell faces. The next is trimmed mesh. This utilizes a template mesh constructed from hexahedral cells from which it cuts or trims the core mesh based on the starting surface. What are the different types of volume mesh and how to choose the volume mesh suitable for current application? Here are some merits and demerits of different mesh types. We will focus only on general purpose meshes right now. First is tetrahedral meshes. These are very dissipative and convergence can be slow. The polyhedral meshes. These produce more accurate results than tetrahedral meshes. There is also faster convergence than tetrahedral meshes. We can also give a conformal mesh at the interface between separate regions. Then comes the trimmed cell meshes. These require less memory to generate than polyhedral mesh, but they do not give conformal mesh at the interface between separate regions. Now, among the specialized mesh type, we will see what options we have. In specialized 2.5D meshers, many types exist. These are prism layer mesher, extruder, thin mesher, generalized cylinder mesher, advancing layer mesher, directed mesher. 2.5D meshing is a synthetic definition of those meshing techniques that exploit the fact that certain special geometries have a general mesh in 2 dimensions, while in the 3rd dimension the mesh has some form of simplification. These simplifications are usually in these different forms. Mesh is extruded in a predetermined direction. Mesh is extruded along the local normal direction. Mesh is swept along a 3D curve as axis.